Yesterday we were discussing the reversible reaction. So reversible reaction means reaction in which the reactant can form a product and the product can decompose and form back the reactants. So reversible reaction means the reactants can form a product and the product can decompose, form back the reactant. We call this reversible reaction. And for reversible reaction, we define a term equilibrium. So the term equilibrium means the rate of forward reaction is equal to rate of backward reaction and no change in amount of reactant or product. So amount of reactant and product will not change. The speed of the forward and the backward reaction will be same, and we call this as reverse equilibrium. This state is defined as equilibrium. So for reversible reaction, but it's not necessary that reversible reactions are always in equilibrium. Maybe equilibrium shifted towards right. The equilibrium may shift towards right or equilibrium may shift towards left. If we say equilibrium is shifted towards right, or forward, so it means that amount of product will increase, or amount of product, or it's also known as a yield. And if equilibrium is shifted towards left hand side, or backward, it means that amount of product will decrease, or we can also say the yield will decrease. This is what we discussed yesterday, the definition of equilibrium as well as shifting of the equilibrium. It might shift it towards left or it might shift towards right. The factors affecting or shifting the equilibrium there are certain factors which can affect the equilibrium or position of equilibrium. Yeah, in this one, I did not mention about the reactant because mainly our main target is to obtain a product. So here what happen if equilibrium is shifted towards right hand side, it means amount of product will increase and amount of reactant will decrease. Where equilibrium shifted towards left hand side means amount of product will decrease and amount of reactant will increase. But mainly our focus is to product, form product or get the product. That's why I specify only the product. Now the factors which shift the equilibrium shifting or affecting equilibrium. The equilibrium can be shifted or affected by amounts of reactant in product. It can be affected by temperature, and it can be affected by pressure, but pressure is only affecting for gases only, gaseous reactant or product. So first factor we will discuss, effect of amount of reactant or product on position of equilibrium. So how the amount of reactant or product affects the position of equilibrium? It is having four parts. Number one, if we add reactant, like if we increase the amount of reactant. Example, you have a reversible reaction in which the reactants are forming a product, and product is decomposing, forming back the reactant again. Example, if it was in equilibrium, originally it was in equilibrium and now we are changing the amount. Example, when it was in equilibrium, you was having 10 grams of reactant and you was having 15 grams of a product. So when it was in equilibrium, example, out of 10, 1 gram is forming a product, and at the same time, 1 gram is forming back the reactant. So there is no change in concentration or amounts of reactant product, and this is a state when it is in equilibrium. Now what we are doing, we are adding a reactant. If I add reactant, like example, I was having 10 gram of reactant, but what I did, I changed the amount of reactant. I made it 20 gram. So now what happened? Look, 10 gram was forming 1 gram of a product. So 20 gram, how much product it will form? The moment when I add, I made 20 gram. So 10 gram was forming 1 gram. 20 gram will form 2 gram, the simplest ratio you can use. So 20 gram will form 2 grams of a product, where the moment when you add, you was having 15 gram of a product. So 15 gram of a product is decomposing and forming back only 1 gram of reactant. So where the equilibrium is shifted when I add reactant? Which direction equilibrium or balance is shifted when we add reactant? So it's shifted towards forward or right hand side. So when we add reactant, equilibrium, in short I'm writing equilibrium EQ, shifted towards right or forward. And if equilibrium shifted towards right, what will happen to the yield? The yield or amount of product will increase. Is it clear? The first part, the factors which affecting the equilibrium, we are discussing the first one, the amount of reactant and product. First part of this, if we add reactant, the equilibrium or the balance shifted towards right hand side or forward direction, so the yield will increase. You can take the screenshot, so I'll move on to the second part. So the second part for this, we are finding the effect of concentration on the shifting of equilibrium. So first we add reactant. If I remove reactant, I'm taking the same example. Like first we have a reaction which is at equilibrium. The reactants are forming a product, and product can decompose. This was say 10 grams of reactant were there and 15 gram of a product. I remove, it was in equilibrium. So 1 gram is forming a product at the same time, 1 gram decompose and form back the reactants. If I remove reactant, example, I was having 10 gram of reactant, but what I did, I made 5 grams now. So if 10 gram was making 1 gram of a product, the 5 gram, how much product it will form? It will form half of what it was forming originally. So this will be 0.5. But the product, it is 15 gram. So it will still form 1 gram of a decompose to 1 gram of a reactant. So which side the equilibrium or the balance is shifted if we remove reactant? So it is shifted towards left hand side. So when we remove reactant, the balance or equilibrium shifted towards left or backward, or you can say the yield means the amount of product will decrease. Is it clear? The second part of factor which affects the position of equilibrium. The third part for factor affecting the position of equilibrium, if we add a product to a equilibrium mixture. So reversible reaction, first it is in equilibrium, we have reactant and we have product. Reactant is forming a product is decomposing and forming back the reactant. So we have 10 grams of reactant, 15 grams of a product at equilibrium. So 1 gram is forming a product, at the same time 1 gram decompose and forming back the reactant. Now if we add a product, like if we increase the product, we were having 15 grams. Now to a equilibrium mixture, we double the amount of product. We made it 30 gram. So 15 gram was forming 1 gram, decomposing into 1 gram of reactant. So 30 gram will decompose into, the 30 gram will decompose into 2 grams of a reactant. And originally, the moment when we add, we were having 10 gram of a reactant. So that 10 gram is still decompose into 1 gram of forming a 1 gram of a product. So you can see the forward and the backward reaction are disturbed, like the rates are changed. So which direction the equilibrium is shifted? So equilibrium is shifted backward or towards left. You can write both. You can write backward or you can also write left. Both are correct. How we can increase the product by changing the amount of the, without changing the amount of reactant. Like example, we are adding, because different reactions may have a common product. So you're adding that product from another reaction. Like you took a product from another reaction and added to this reaction mixture. You're not forming that product from the same reactant. Like you have, if I say A and B were reactant and forming a product C. So, and there's another reaction which can produce a product C. So using that product, you're adding to this reaction mixture.
Sir,
Yes.
sir, like when we are doing this reversible reaction, like in the same container, both A and B and C, all of the three are like present.
Yeah, all of them are there. Like you have in a reaction mixture, you have A, you have B, and you have C, because it's a reversible reaction. So it means you will have all of them. You will have reactant also, and you have product in the same container. And now what you're doing, like for example, another reaction produce a product C, and you're using that product and adding to a reaction mixture. Is it clear?
Yes, sir. Thank you.
So equilibrium shifted towards left. So if equilibrium is shifted towards left, what will happen to the yield? The yield will decrease. And the last part for the reversible, for changing the concentration. So if we remove the product from the reaction mixture, so we have reactant which is forming a product, and we have product which decompose and form back the reactant. Example, the it was an equilibrium. The reaction mixture was an equilibrium, 10 gram producing this 1 gram, and 15 gram was also decomposing into 1 gram. So there is no change in concentration. But what happened if you remove the product? Like you was having 15 gram, but what you did, you made 7.5. Like you remove the only the product from the reaction mixture. So if you remove the product from the reaction mixture, what happened? If 15 gram was formed decomposing into 1 gram of a product, so 7.5 will decompose into half of the original value, so which will be 0.5 grams. So 0.5 gram of reactant will form, and still the 10 gram of a reactants are there, so which react to form 1 gram of a product. So you can see the forward reaction rate is faster. So we can say the equilibrium is shifted towards right hand side or forward. So the effect of concentration, simply we can say the first factor, which is the effect of concentration of reactants or product. So if we add reactant, because the possibilities, we can add reactant, we can remove reactant, we can add product, we can remove product. So when I add a reactant, where the equilibrium was shifted, if we add reactant, which direction the equilibrium shift? So it will shift towards right hand side. So if you want to represent by even by arrows that equilibrium is shifted towards right hand side or forward, so right hand side arrow should be longer, and left hand side arrow, the arrow which is pointing towards left, should be shorter. Like it shows that the forward reaction is faster and the backward is slower. If you remove the reactant, where the equilibrium will shift? So equilibrium is shifted towards the left hand side. If equilibrium is shifted towards the left hand side, so when I draw the arrows, the right hand side arrow should be shorter and the left hand side arrow should be longer. I can just use these arrows as a representation of shifting of equilibrium between the reactant and product. If we add a product, where the equilibrium will shift? So if we add a product, equilibrium will shift towards left hand side or backward. So how to represent a backward? The right hand side arrow should be shorter and the left hand side will be longer. And if we remove the product, the equilibrium will shift towards right hand side. And as the equilibrium is shifted towards the right hand side, So we can represent by the arrows. The right hand side arrow should be longer and left hand side should be shorter. If it is in equilibrium, then we will use two arrows of same length. But if its equilibrium is shifted, then one of the arrow, which is side it is shifted, should be longer than the opposite direction. So this is the first factor which affects or shift the equilibrium. We can add reactant or remove product, or we can remove reactant or add a product, and we can shift the equilibrium. You can take the screenshot of this. Then the second factor which affects the equilibrium is the temperature. But the temperature is having a different effect for different type of a reaction, because the reaction can be a forward reaction can be endothermic, a forward reaction can be exothermic. Example, if the forward reaction is endo, or a forward reaction is exo, because it is having a different effect to different type of a reaction. So if you have endothermic reactions, and if I make an energy diagram, which one will have high energy, reactant or product? If endothermic reaction, and we are making an energy diagram, which substance is having a high energy, reactant or product? For endothermic reaction, we supply energy. So when we supply energy, so reactant absorb energy and they form the product. So reactant will have low energy and the product will have high energy. So for endothermic reactions, the reactant is having a low energy, where the product is having high energy. If the forward reaction is exothermic reaction means the product is formed when the reactor loses their energy to the surrounding. So the product will not have too much energy. So reactant will have more energy and the product will have high energy. So reactants having high energy compared to that of product, reactant loses their energy to the surrounding and form the product. So this is an energy diagram for reactant and product. Now, because it's a reversible reaction, so when we say it's a reversible reaction, it means the reactant can form a product and product can form back the reactant. Same thing, a reactant can form a product and the product can decompose and form back the reactant. Example, if it is an if it's an endothermic reaction, the forward reaction is endothermic. For reversible reaction, we have both reactant and product. And what we are doing now, we supply heat energy. We increase the temperature or supply energy. So what we have both reactant and product, but we are supplying energy to both. I'm supplying energy to the product as well. I'm supplying energy to reactant because we have both reactant and product. So what happened? The product is already having high energy. So even it absorb energy, but it cannot form new thing. But what happened as energy is absorbed by the reactant? So if energy is absorbed by the reactant, what it will form? It will form more product. So if we increase the temperature or supply the energy, So what happened? Reactants can absorb energy, product can also absorb energy. But when reactant absorb energy, you can see the reactant after absorbing energy, they can form a product. So if the reactant can form a product by absorbing energy, so what it will result? If we increase the temperature, so equilibrium will shift towards right hand side or forward. Is it clear? Because what happened, we have a reaction mixture, we have both reactant and product, and we are supplying energy. So when we are supplying energy, so equilibrium shifted towards right, forward, or the yield will also increase. Is it clear? When we supply energy, what happened? The product can also absorb energy, reactant can also absorb energy. But when reactant absorb energy, you can see the reactant after absorbing energy, it can form a product. So amount of product will increase or equilibrium shifted towards right or yield will increase. So for endothermic reaction, when we have a reversible reaction at equilibrium and we supply more energy or increases the temperature, it will shift the equilibrium towards right hand side. And opposite will happen. Opposite will happen. We have reactant and the product. If we decrease the temperature, or we remove the heat energy. So when we decrease the temperature or remove the energy, both reactant and product can lose their energy. But what happens when the product loses energy? What it can form? When the product loses energy, it can form back the reactant because the reactant is having low energy. So when we decrease the temperature or remove the energy, where the equilibrium will shift? Equilibrium will shift towards left because the reactants are forming more, or we can say backward, or the yield will decrease. Here the yield was increasing, and this part the yield will decrease. Is it clear, this explanation? When endothermic reaction is there and a reaction is reversible as well, we are removing the heat energy. So when we remove the heat energy, most of the energy is lost by the product because the product is at high energy, and when the product loses energy, it will form back the reactant. Is it clear, this part? Then if a forward reaction is exothermic, forward reaction exothermic means the product is having low energy and the reactant is having high energy. And now what we are doing, we are supplying energy. So if we supply energy, reactant can also absorb energy, product is also can absorb energy. But what happened when the product absorb energy, what it form? It will form back the reactant. So as it form back the reactant, where the equilibrium is shifted. When we supply energy, the product absorb energy and it can form back the reactant. So as it can form back the reactant, the equilibrium is shifted towards left hand side or backward, and the yield will decrease. And opposite will happen. We have reactant and the product, and we are removing the heat energy. We decrease the temperature or remove the energy. So we have both reactant and product, and we are removing the energy. So the product can also lose energy, but product cannot form new thing by losing the energy. But as the reactant lose energy, you can see the reactant can form a product because the product is having low energy. So what happened? The reactant will form a product as we decrease the temperature. So if more product is formed, what we say equilibrium shifted towards right hand side or forward, or the yield will increase. So this is the effect of temperature on reversible reaction, but you have to check whether a reversible reaction is endothermic or exothermic. If a reversible reaction is endothermic, we increase the temperature, it will shift towards right hand side. If we decrease the temperature, it will shift towards left. But if a reversible reaction is exothermic, if we increase the temperature, it shift towards left, and decrease the temperature, shift towards right hand side, or shift the balance or equilibrium towards right hand side. Is it clear, this part, effect of temperature on position of equilibrium? Any doubt in this? So when we increase the temperature for endothermic reaction, so you can see you have reactant and you have product, and you're increasing a temperature. Increasing a temperature means supplying. So when you supply energy, so what happened? When product absorb energy, product cannot form new thing by absorbing energy. But what happened? The reactant, when it absorb energy, the energy of reactant increase. As the energy of the reactant increase, it will form more product. That's why equilibrium is shifted towards right hand side or forward. So for endothermic reaction, you're supplying energy. Product is already having high energy. When product is having high energy and you're supplying energy, so it will not make difference to the product. But when you supply energy, most of this energy reactant absorb and it will form a product. And the last factor which affects the equilibrium is the pressure. This is valid only for gaseous reactant and product. Even a reactant or a product, any of them is a gas, then this will affect the equilibrium. So example, if we increase the pressure, it means we reduce the volume, which shift the equilibrium towards the side of less particles of gas. So how it affect, like I will use the equation here. Example, you have A plus B, or say 2A plus B gives C. A is a gas, B is also a gas, and C is a gas. It was in equilibrium, balance. Now you have a container, because the reaction mixture is there, it's inside the container. and it was at equilibrium. So A, two molecules of A, one molecule of B, and then C is there. And this is balanced or it is at equilibrium. Now what we are doing, we are increasing the pressure. If I increase the pressure, so when I increase the pressure, basically I reduce the volume of the container. So when I increase the pressure, means I reduce the volume of the container. So it increases the collision between the particle. The particles will collide more often. But as you can see, we have greater proportion of the reactant particle as compared to product particle. Like in a mixture, the proportion of the reactant particle is higher as compared to the particle of the product. So as we increase the pressure, as we apply more pressure on this, so we reduce the volume. When we reduce the volume, so increase in pressure, reduce the volume, which cause more collision between the particle of greater proportion and shift the equilibrium towards other side. So you can see how many particles of reactant are there. The total number of the particle of reactant, we have 2A and we have 1B. So we have 3 particles of the reactant. How many particles of the product are there? The C, only 1 particle of a product. So when I increase the pressure, when I increases the pressure, I reduce the volume. When I reduce the volume, means the particles will collide with each other, but which particles will have a greater collision? The reactant particle will have a greater collision. Why they will have a greater number of collision? Because they are in a greater proportion. So as they are in a greater proportion, when we increase the pressure, they collide more often. So as they collide more often, the equilibrium or the balance will shift towards the opposite side. So in this case, it will shift towards right hand side. Is it clear? The shifting of the equilibrium. So whenever you increase the pressure or you reduce the volume, it will always shift the equilibrium towards the side where particles are less. And why it happen? Because when you increase the pressure, you reduce the volume. When you reduce the volume, so the particles which are in greater proportion in the mixture will have more collisions. As they have more collisions, this will result in a shifting of equilibrium in the opposite direction. Is it clear, this part? The shifting of the equilibrium. And this is only valid for gases because gases are compressible. You can compress the gas, you can change their volume by pressure. That's why it is only valid for gaseous reactant or product. If you don't have a gaseous reactant or product, means this will not change. Example, another reaction, N2 plus 3H2 gives 2NH3. How many particles of reactant are there in this equation? The particle, when you count the particle, you just take this coefficient. Don't bother about the total, just the molecules. So there are 4 particles of the reactant. How many particles of the product? 2. So there are 4 particles of the reactant and 2 particles of the product. So we have greater proportion of the reactant particle as compared to that of product particles. Now what we are doing, we are increasing the pressure. If I increase the pressure, where the equilibrium will shift? Which side the equilibrium will shift if I increase the pressure? So it will shift towards the side where less particles are there. So it will shift towards right hand side or forward. So increasing a pressure will shift the equilibrium towards right or forward for this example. If there is another reaction, H2 hydrogen plus chlorine gives hydrogen chloride. This one is gas, gas, and also gas. What will be the effect of increasing the pressure? How many reactant particles are there? What is the number of the reactant particles? 2. What is the number of the product particle total? So total number of the product particle is also 2. So you have 2 reactant particles and 2 product particle. When you have equal number of the particles of gas, then there is no effect of pressure on equilibrium. So if you have equal number of the reactant and the product particle, then there is no effect of the pressure on the position of equilibrium. Another reaction, say carbon was reacting with oxygen, forming carbon dioxide. This is solid, this one is gas, this one is also a gas. I'm increasing the pressure. Where the equilibrium will shift? If I increase the pressure, so there will be no effect. Why there will be no effect? Because you always check the gaseous reactant and product. It will remain the same because you don't check the total reactant particle, you check the particles of the gas. So how many particles of the gas are present in the reactant side? 1. How many particles of a product? 1. So if you have equal number of the gaseous particle, then there is no effect of pressure on equilibrium. Is it clear? So these are the 3 factors which change the equilibrium. I will quickly go through all of them and discuss some questions related to this topic from the past paper. So first, the 3 factors which can affect the equilibrium: amount of reactant product, temperature, or pressure of the gas. If we add reactant, equilibrium will shift towards right hand side. If we remove reactant, equilibrium will shift towards left hand side. If we add a product, equilibrium will shift towards left hand side. If we remove product, equilibrium will shift towards right hand side. So this is how we represent right, left, left, right for changing the amount of reactant or product. If a reaction is reversible and it is endothermic, then increasing a temperature shift towards right, decreasing a temperature shift towards left. If a reaction is exothermic, increase in temperature shift towards left, and decrease in temperature shift the equilibrium towards right. The pressure is only valid for gaseous reactant. Remember this statement that when you increase the pressure, it means we reduce the volume, so it will always shift the equilibrium towards side where number of the gas particles are less. So now we'll do some questions related to this equilibrium. The position of how the position of equilibrium is affected. Okay, in this question, steam react with carbon in an endothermic reaction. Which condition of temperature and pressure would give the largest yield, means amount of a product? The reaction is endothermic. So it's better you just make an energy diagram. So react endothermic means the reactant will have low energy and the product is having high energy. So what I should do to the temperature to get more hydrogen? I should increase the temperature or decrease the temperature? If I want more hydrogen first. So I should increase the temperature because that will shift the equilibrium towards right. So either A can be answer or B can be answer. But what about the pressure? When you check the moles, here we have one molecule of a gas and the product side we have two molecules. So if I increase the pressure, the equilibrium will shift towards left hand side. So I should not increase the pressure, I should decrease or lower, because if I increase equilibrium shifted towards the side where less particles. So the correct answer is B. Is it clear, this question? Because if I increase the pressure, the equilibrium will shift towards left hand side, so I'll get the yield will decrease. Which row describe how this is related to the rate of reaction? Nitrogen, hydrogen, and ammonia gas are placed inside a container. The container is then sealed, like it does not allow anything to enter or leave. After some time, equilibrium form. What is the meaning of equilibrium? Which statement describe equilibrium in the container? What's the right answer? Yes, C is the right answer, because what happened, the rate at which the ammonia formed is same as rate at which it decomposed. Like if 2 grams of ammonia is formed, at the same time 2 gram of ammonia will decompose, so it will be C. Why other statements are not correct? Amount of ammonia remain constant for the moment the container is sealed. No, not that moment, it will remain constant throughout. The amount of ammonia, nitrogen, and hydrogen is always equal. That's totally wrong. Like it does not mean that you have 2 grams of nitrogen, 2 grams of hydrogen, and 2 grams of ammonia. That is not equilibrium. The rate C's are the rate of formation of ammonia is faster. If rate of formation is faster, it means the equilibrium is shifted towards right hand side, not it is at equilibrium. The reaction used to manufacture ammonia from nitrogen, hydrogen is reversible. An equilibrium is established between ammonia, nitrogen, and hydrogen. Which statement describe the equilibrium? Yeah, that's right. A is the correct answer. Equilibrium means when the forward and the backward reaction occur with the same speed or same rate. We call that as equilibrium. What could be the answer for question 14? The forward reaction is endo. Yeah, that's right. Because the forward reaction is endo, so if I make an energy diagram, the reactant will have low energy and the product will have high energy. So when I increase the temperature, I will get more product, means I'll get more carbon monoxide and hydrogen. And what about the pressure? Because if I check 2 moles of reactant and 4 moles, so if I increase the pressure, equilibrium will shift towards left hand side. So I should decrease because I want to shift towards right. So low pressure and high temperature. Question 18. When the system has reached equilibrium, more T is added. After addition of T, which substance increase in concentration? First thing you should understand, like adding T means adding a product. So if I add a product, where the equilibrium will shift? Yeah, that's right. C will be the correct answer because when I add more T, equilibrium shifted towards left. So if equilibrium shifted toward left, amount of product will decrease and amount of reactant will increase. In this question, question 22, at 400, the reaction between hydrogen and iodine reach equilibrium. The reaction is exothermic. Exothermic because the energy change is negative, so exothermic. The question is, which change in the condition would increase the percentage of hydrogen iodide in the equilibrium mixture? The reaction is exothermic, means the reactant have more energy and the product will have less energy. Look, the pressure will not affect because 2 moles of reactant, 2 moles of product. So pressure will not affect. So A and C cannot be an answer. Now, because the reaction is exothermic, if it's an exothermic and I decrease the temperature, when I decrease the temperature, I have both reactant, hydrogen iodide is there as a product, and hydrogen and iodine are the reactant. So when I decrease temperature, you can easily understand from energy diagram. So removing the energy, I will get more product. If I'll get more product, it means I should decrease the temperature. So B is the right answer. Question 26. Which change increases the yield of chlorine? Means amount of chlorine. The reaction is exothermic, means the reactant have high energy and the product is having low energy. So what could be the answer for question 26? Yeah, that's right. A is the correct answer. Because look, I will discuss all the factors. If we add more hydrogen, sorry, if we add more water, equilibrium will shift towards left hand side. So that's wrong. If we decrease the pressure, when you check the pressure, 4 plus 1, 5 moles, and 2 plus 2, 4 moles. So increase the pressure, shift towards right. So decrease in pressure will shift in opposite direction. So that's also wrong. And increasing a temperature, because a forward reaction is exothermic, so reactant have more energy, product is having less energy. Increasing a temperature, shift it towards left hand side. Question 31, what's the right answer? The forward reaction is endothermic. So if the reaction is endothermic reaction, the reactants have low energy, product is having high energy. So you should increase the temperature to get more product. And what about pressure? When you check, you have 2 moles of reactant, you have 4 moles of a product. So if I increase the pressure, equilibrium will shift towards left hand side. So I should not increase, I should decrease the pressure. So C is the right answer. The rate of the reaction, motion, when we change the pressure, the rate will change. But what happened? Because look, how these reactants, when I say the number of the particle in the mixture, you have CH4, okay, and you have H2O. Then 3 hydrogen molecules and carbon monoxide. Now what you are doing, if you increase the pressure, it is inside the container and you're increasing the pressure. So the moment you increase the pressure, the space decrease for the particles. So they have more collision, greater proportion of the react product molecules are there. So they will have more collision. As a result, they will form product, more product, like rate of formation of a product will be higher as compared to that of reactant. But as you reduce the pressure, you increase the volume. So as you increase the volume, because even the reactant particle, the product particle, even though they are in a greater proportion, but to form a product, they should collide with each other. But they are not able to collide with each other because of greater volume. So less collision means less rate of for backward. And then what happened? These are only two particles. So the moment they collide with each other, they will also have less collision, the rate will decrease. But compare the chance, what happen if they collide with each other, only two particles have to collide. And here in the react product side, four particles must collide together to form a product, to form a reactant. But here only two particles must collide and form back the or form the product. So this chance that two particles collide and form a product will be higher as compared to four particles will collide and form back the reactant. So that's why the equilibrium is shifted towards right hand side, even though the rate of the reaction will decrease for forward and backward. But we are not talking about rate. Rate will decrease for both, but in comparison, the rate of forward will be higher as compared to backward. Is it clear? Question 34. The forward reaction is exothermic. Reactant have high energy, product will have low energy. The question is which changes would increase the equilibrium yield of sulfur trioxide, like shift the equilibrium. So increasing a pressure because 3 moles 2, that's right. Lowering a temperature, that's also correct, you will get more. But if you decrease oxygen, if I reduce the amount of oxygen, equilibrium will shift towards left hand side. So that will be wrong. So B is the correct answer. Rate of the reaction, if you remember the factors which affect the rate is affected by concentration, surface area, temperature, pressure, catalyst. So which row shows the effect of increasing the pressure on equilibrium mixture? The rate of the reaction, amount of sulfur dioxide, and amount of sulfur trioxide. If we increase the pressure, increase in pressure, that's the rate will increase as the equilibrium shifted towards side where number of moles are less. So amount of sulfur trioxide decrease and amount of sulfur dioxide will decrease and amount of sulfur trioxide will increase. So A will be the answer because pressure affects the rate, increase in pressure, increase the rate. Then what happened? You have total 3 moles of reactant and you have 2 mole of a product. So where the equilibrium shift? When you increase the pressure, equilibrium is shifted towards right hand side. So if equilibrium is shifted towards right hand side, amount of sulfur dioxide will decrease and amount of sulfur trioxide will increase. So A is the right answer for this. In this question, bismuth trichloride BiCl3 react with water to form a white precipitate of BiOCl. The equation is shown. So BiCl plus H2O gives BiOCl plus 2HCl. Which statements are correct? The reaction is reversible. That's correct. You can see this arrows. When dilute hydrochloric acid is added to a reaction mixture, more white, this is a white precipitate. So if I add hydrochloric acid, if I add more hydrochloric acid, where the equilibrium will shift? So equilibrium will shift towards left hand side. So if equilibrium shift towards left hand side, amount of BiOCl or white precipitate will decrease. So this is not correct. The third one, when aqueous sodium hydroxide is added, more white precipitate. Look, when you add sodium hydroxide, you don't see sodium hydroxide in the equation. But can you identify which substance can react with sodium hydroxide, alkali? Which substance can react with sodium hydroxide? The HCl is an acid. So basically what happened, when you add sodium hydroxide, HCl will react with sodium hydroxide, acid react with alkali. So amount of hydrochloric acid will decrease. As amount of hydrochloric acid decrease, the equilibrium will shift towards right hand side. So as equilibrium will shift towards right hand side, it will form more white precipitate. So which statement, the question is which statements are correct? So statement 1 and statement 3 are correct. Statement 2 is incorrect because if you Add hydrochloric acid, equilibrium will shift toward left hand side. So amount of white precipitate will decrease. Is it clear, this question? So basically the third statement was like removing a product, and how you remove a product? By adding another substance which can react with the product. The forward reaction is exo. Which condition produce the highest equilibrium yield of methanol? C is the right answer because the reaction is exothermic, so reactant have high energy, product having low energy. So you should decrease the temperature and pressure. 3 moles of reactant, 1 mole of a product, so equilibrium shifted towards right hand side if you increase the pressure. Question 45. So the pressure, you want the equilibrium to shift towards right. So you should decrease the pressure because 2 moles of reactant and 4 mole of a product. So decrease the pressure, and the forward reaction is endothermic. So increase the temperature. So B is the right answer. Okay, in this question, ammonia is produced in a Haber process, can be oxidized. Oxidized means oxygen is added to form nitrogen dioxide at 900. The reaction is exothermic. Balance the equation. What will be the balance, the numbers here? What will be the balance equation for this? So nitrogen, we put 4, and 4 multiplied by 3 is 12. So we put 6. And then for oxygen, total 4 plus 6, 10 are there. So we put 5. Now, suggest a reason other than the cost why the temperature greater than 900 is not used. Like this reaction, they already mentioned it's an exothermic reaction. Exothermic reaction means the reactant have high energy and the product is having low energy. So why we did not use the temperature like too high temperature like 900 or above? So that will lower or decrease the yield. That's right. So the amount of product or the yield will decrease. Suggest a reason why a temperature less than 900 is not used. So because the temperature increases the rate, so reason why very low temperature is not used. the reaction rate of a reaction will be very low, or because some of the reactants are inert in nature at certain temperature, the reaction only started at like 400, 500. So that's why we use a temperature around 900, not too high, more than 900, so that the amount of product will not decrease too much, and not too low, otherwise the speed of the reaction will be too slow. Okay, in the next question, ammonia is also made by ammonium carbonate decomposition. Like ammonium carbonate solid decomposed into ammonia plus water plus carbon dioxide. The reaction is reversible, can reach the position of equilibrium. The graph shows the yield of ammonia at equilibrium changes with temperature and pressure. Like yield means amount of ammonia, the product basically. What is meant by the term equilibrium for a reversible reaction? It's of 2 marks. So how you will score 2 marks? You will first mention that the rate of forward is equal to rate of backward, and the second mark is there is no change in concentration of reactant and product. Then the second part, use the information, explain whether the reaction is endothermic or exo. Use this information, the temperature. Can you identify whether this reaction is endothermic or exothermic? The forward reaction. The reaction is endothermic because you can see at high temperature you are getting a more product. So use information from the graph. You can see like at 300, when the temperature is 300, we are getting more product as compared to when temperature is 100. So the reaction is endothermic. State and explain effect of increasing pressure on yield of ammonia. If we increase the pressure, you can see the number of mole of gas 4 and here 0. Where the equilibrium will shift? As we increase the, yeah, so as the pressure increase, the yield will decrease. And what is the reason? Because they ask for explanation. So what you will explain, you will mention because less number of moles of gas, equilibrium shifted towards left hand side, less number of moles of a gas. So yield decrease because more moles of the reactant or less number of moles of the product moles of the product, or more moles of a gas on the right hand side. So position or equilibrium shifted towards left. So it's of 3 marks, and the distribution of the mark, like the score, you will mention the yield will decrease because more moles of gas on right hand side, which so increase in pressure, shift equilibrium towards left or side of less moles. Okay, in this question, sulfur dioxide is converted into sulfur trioxide according to the following equation. The reaction is carried out around 450, 1 or 2 atm using a catalyst. Delta H is negative, means the reaction is exothermic. What's the meaning of this symbol? So it is reversible reaction. Name a catalyst used, that we will do in the sulfur chapter. So I'm leaving that. This part is we will discuss in sulfur chapter. Why is a catalyst used? What is the purpose? Why we use a catalyst for this reaction? Purpose of the catalyst is to speed up the reaction or rate, increase the rate. If a temperature if a temperature higher than 450 is used, what will happen to amount of sulfur trioxide? The reaction is exothermic. So reactants have high energy, product is having low energy. If we increase the temperature more than 450, what will happen to amount of sulfur dioxide? The yield will decrease, and you can mention, give a reason for your answer. So you'll mention the equilibrium will shift towards left hand side. The forward reaction is exothermic, so increase in temperature will shift the equilibrium towards left hand side. Yeah, the higher rate of decomposition of sulfur trioxide as compared to formation of sulfur. Your higher rate of because the yield will decrease or decomposition will be higher for sulfur trioxide as compared to formation. Suggest a reason why a temperature lower than 450 is not used. Like why we did not use too low temperature, less than 450. So if we use a temperature below this, the rate of a reaction will be slow, or the rate of reaction will be slower or too slow, you can mention. Okay, in this question, this is also related to reversible reaction. You can see aqueous potassium dichromate is there. This is aqueous potassium dichromate, which is yellow in color. Uh, sorry, aqueous potassium chromate is there, which is yellow in color, and dichromate is there, in which is orange in color. The two compounds are interconvert, means they can change from one to another when the pH of the solution changes. Solution Y is a mixture of potassium dichromate and potassium chromate and dichromate. Explain in terms of position of equilibrium what you would see if sulfuric acid is added. If I add sulfuric acid, where the equilibrium will shift? If I add more sulfuric acid, H2SO4, where the equilibrium will shift? Yeah, because we are adding a reactant. So if we add sulfuric acid or reactant, equilibrium shift towards right. So if the equilibrium will shift towards right, what will be the appearance of this solution? It will be yellow or orange? So it will be orange. So you will mention adding. So if sulfuric acid is added, the equilibrium is shifted towards right. And what about in terms of position of equilibrium, what you see if sodium hydroxide is added? But in this question, again, you don't see sodium hydroxide anywhere as reactant or product. But now then what you have to do, you have to check which substance can react with sodium hydroxide. Which substance in a reactant or product can react with sodium hydroxide? So sulfuric acid, H2SO4. So basically what happened, this sulfuric acid will react with sodium hydroxide. So amount of sulfuric acid will decrease. So where the equilibrium will shift, it will shift towards left hand side and you will see or observe a yellow color. H2SO4 is an acid. So acid can react with an alkali. Acid alkali reactions are there. That's why H2SO4 is reacting, which cause the equilibrium will amount of sulfuric acid to decrease, shifting the equilibrium towards left hand side. So these are the questions related to a reversible reaction. Reversible reaction is not a full chapter. You don't find in the book as a chapter, but you will find question in the past paper, a complete question. So any doubt related to the class today? Okay, so I'll end the session and share the recording.